I am Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today we will discuss about dynamic characteristics of a measuring instrument and permanent magnet moving coil meter. Coming to the statistical analysis, the main aim of the statistical analysis is to do the experiment n number of times. With that we get the accurate results. As we know that in statistical analysis, we are taking the readings, or we have n number of readings for the similar pattern. So, if we have n number of readings for the similar pattern, we can calculate accurate value. That is the main aim of using statistical analysis in measurements and instrumentation. In this statistical analysis, we have four main parameters like mean, deviation, average deviation and standard deviation. So, normally if you are doing an experiment in a single time, if you get the result and we thought that is the correct result. But sometimes the result we have obtained may not be correct. So that we don't know. So to get accurate readings, we are using statistical analysis. In this first one is mean. Mean can be defined as total number of readings, sum of total number of readings to the count. That is, let x1, x2, x3 and so on xn are n readings of a particular measurement. The mean or average value of these readings can be calculated as mean equal to x1 plus x2 plus x3 and so on xn by n, where x1, x2, x3 and so on xn represents the number of readings and small n represents the count, how many number of readings we consider here. So in this mean calculation, we are doing the experiment first time, that is represented as x1, and the second time that is indicated with x2, third time x3 and so on xn. We are doing the experiment n number of times to find out the mean, sum of all the readings divided by total number of readings. Sum of all the readings means x1 plus x2 plus x3 and so on xn divided by total number of readings n. This gives mean value. And next one is deviation from mean. The difference between the reading of a particular measurement and the mean value is known as deviation from mean, or we can also call it as deviation. So, if you are taking the readings while doing the experiment, we are obtaining the value as x1. Instead of x1, we are getting some another value like x1 dash. The variation in the original value or the average value to that of value obtained in particular case, that is called as deviation from mean. Deviation from mean can be represented as d1, which is equal to xi minus m, where di is the deviation of ith reading from mean, whereas xi represents the value. Average deviation. To obtain the average deviation, we have to consider deviation in each case, sum of all the deviations divided by total number of deviations. In this case, while calculating the average deviation, instead of taking direct readings, we consider modulus. Modulus of d1 plus modulus of d2 plus modulus of d3 plus modulus of d4 and so on, modulus of dn divided by n. Why we consider modulus means, if you are obtaining the deviation value, that may be positive or negative. If you consider both positive reading as well as negative reading in terms of modulus, the obtained result will be an accurate result. So, while taking average deviation, we need to consider modulus. Next one is standard deviation. In this standard deviation, we have two different parameters. The standard deviation, while we are calculating for more than 20 readings or less than 20 readings. If the standard deviation is calculating for more than 20 readings, then the standard deviation sigma can be represented as square root of d1 square plus d2 square plus d3 square and so on dn square by n number of readings. Here d1 represents deviation from mean 1, d2 deviation from mean 2, d3 deviation from mean 3. So in this we consider the square root of deviation is called as standard deviation. If you take the number of readings which are greater than 20, we have to consider total number of readings. If the number of readings we are taking are less than 20, then we can represent the standard deviation as sigma equal to square root of d1 square plus d2 square plus d3 square plus and so on dn square by n minus 1. So based upon number of readings we are considering, number of readings we are taking, the standard deviation, we have different formulas. For n value less than 20, we have to consider n minus 1 in the denominator section. If n value is greater than 20, we need to consider this formula. So all these statistical analysis will provide accurate and correct result. At the same time, the result obtained with the help of the statistical analysis is very fast. And next one is PMMC meter. Why we have studied about this PMMC meter? What is the need of PMMC meter? The another name for this PMMC meter is D'Arsonval meter or D'Arsonval movement. Why? Because the scientist who invented this PMMC meter, with that name we can call it as D'Arsonval movement or D'Arsonval meter. The another name for this one is PMMC meter. Why we call it as PMMC meter means PMMC, which represents permanent magnet moving coil meter. So a moving coil that is inserted, a moving coil is inserted between a permanent magnet. So it is called as permanent magnet moving coil meter. So first of all, see the construction of this PMMC meter. In this PMMC meter, we have a permanent magnet which consists of north and south poles. Along with this, a meter movement and a scale is present. A pointer is connected here. So the leads of the meter is connected to any device. Here the current passing through the meter can be indicated with the readings on the scale. The readings on the scale can be noted down with the help of pointer present here. So if you see the construction, which consists of a permanent magnet, a pointer, scale and moving coil. The moving coil consists of two leads. The two leads of the moving coil are connected to a meter. Here, whenever current passing through the meter, then the number of turns present in the coil will rotate. Because of the current passing through this coil, the coil will rotate. So whenever this coil rotates, the pointer which is connected to the coil also rotates, and which indicates the reading on the meter scale. With that we can find out the how much amount of current passing through the moving coil. In this way we can measure current passing through the moving coil with the help of PMMC meter. So if you observe this construction, whenever current passing through the coil, as the current passing through the coil increases, there is a movement in the coil. Based upon the number of turns present in the coil, it produces some torque, and due to this there exists some movement in the coil. Whenever the coil moves, it will rotate. Along with this coil, the pointer which is placed on the coil will also rotate, that is displayed on the scale. With that scale reading, we can measure the amount of current passing through the coil, and this is called as permanent magnet moving coil meter. With the help of this PMMC meter, we can measure voltages and currents. Here, by using this PMMC meter, we can measure DC voltage and DC current. For example, if you consider a circuit and a PMMC meter is present here at the output section. A PMMC meter is present at the output section and a resistance is connected in parallel with the PMMC meter. That resistance is represented with shunt resistance RSH. If a resistance is connected in parallel with the meter movement, then the circuit will be acting as an ammeter. Similarly, connect a PMMC meter at the output section and PMMC meter is connected in the output section. Similarly, a series resistance is connected. Then the circuit will be acting as an voltmeter. If a resistance is connected in parallel with the meter movement, then the circuit will be acting as an ammeter. Similarly, if the resistance is connected to the PMMC meter movement in series, then the circuit will be acting as an voltmeter. Based upon the resistance we have connected across the PMMC meter, if the resistance is connected in parallel with the meter movement, then the circuit will be acting as an ammeter. Similarly, if the resistance is connected in series with the meter movement, then the same circuit will be acting as an voltmeter. If you want to measure single voltage or single current, single resistance is enough to measure the readings. But if you want to measure multi-range voltage or multi-range current, we need to connect more number of resistances. For example, if you consider an ammeter, in this a resistance is connected in parallel with the meter movement. With the help of this resistance, we can measure current readings. But if you want to measure different currents with the help of a single circuit, then instead of using single resistance, we can use n number of resistances. We can connect n number of resistances together. This is RSH1 and this is RSH2, RSH3. All these resistances can be connected to the meter with the help of a switch. This switch is called as make before break switch. Why we call it as make before break switch means, for example, if you want to measure a current, minimum current, then we can connect a single resistance, that is RSH1 is connected with the help of a switch in parallel with the meter movement. Suddenly, if you want to change the resistance value, so that first of all we have to make the connection to a corresponding resistance value, then only we need to remove the previous connection. That is called as make before break switch. If you connect the second resistance earlier and then remove the connections already exist with the resistance RSH1, then we can avoid overloading effect that is present across the output section. Sometimes if you want to make any connections, first of all we are removing the present connection. In some cases, if you want to connect to the resistance R1, RSH1 with the help of switch S, we can connect the resistance RSH1 and we can measure the output readings. If you want to change the connection from RSH1 to RSH2, in some cases, we are removing the connection from the first resistance, then we make the connection across the second resistance with the help of a switch. But if that happens, there exists some overloading effect and the time interval between connection of resistance RSH2 to a particular circuit, there exists some ground problems. To overcome these two problems, before removing the connection across the first resistance value, we make the connection across the second resistance and then remove the connection from the first resistance. Then according to our requirement, we can measure the current readings. So, if you want to measure single current, we need to correct only one resistance, that is in parallel with the meter movement. If you want to measure different current readings, then we have to connect more number of resistances in parallel with each other, and each resistance is parallel with another resistance. At the same time, the particular resistance is in parallel with the meter movement. This is the construction of multi-range ammeter. With the help of multi-range ammeter, we can measure different current readings. If you consider a normal circuit of an ammeter, in this is PMMC meter and this is resistance RSH1. In this case, if you want to measure the resistance value to find out a particular amount of current, we need to consider the expression as VSH is equal to VM. But we know that V equal to I into R. So VSH can be represented as ISH into RSH, which is equal to VM. VM means the current passing through the meter into the internal resistance present across the meter. IM into RM. So from this we can measure the unknown resistance or parallel resistance as RSH is equal to IM into RM by ISH. So here the unknown resistance or shunt resistance is equal to IM into RM by ISH. This ISH represents shunt current and IM represents current across the meter. But we know that the total current present in the circuit is equal to ISH plus IM. From this, ISH can be represented as I minus IM. So replace this ISH with I minus IM. Then the expression can be represented as IM into RM by I minus IM. RSH can be represented as shunt resistance RSH is equal to IM into RM by I minus IM. In this equation, RSH represents shunt resistance or the resistance which we need to calculate, and IM represents the current passing through the meter. RM represents the internal resistance present across the meter, and I represents the total current passing through the circuit, and IM represents the meter current. By knowing the internal resistance RM and meter current and total current present in the circuit, we can measure the unknown resistance or parallel resistance. With this unknown resistance, we can measure the amount of current passing through the circuit. And the textbook I have followed is H.S. Kalsi. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.